Number 6, we want to simplify the expression without using a calculator. So we're going to be using properties of logs and the power table to rewrite this. Also some properties of exponents. Set this equal to x, and I'm going to first write it in exponential form. So move the 14 over, and so this will be 14 to the x power is equal to this right here. So it's going to be equal to the square root of 1 over 14. Now, since 14 is in the numerator, there's no fraction, I want it to move to the bottom like this, but also have a square root, and I want to rewrite that because I have a power, and over here it doesn't look like I have one. So rewriting the radical, this is 14 to the power x, and radical, this is understood as 2. What do we multiply times itself twice? So this will be equal to 1 over 14 to the 1/2 power. If I want to move this 14 up so it looks like this one, I need to make it a negative exponent. So 14 to the x, this is property of exponents. This is the same thing as 1 times 14 to the negative 1. You're moving that up, and this is still to the 1/2 power. 14 times 1 is still 14, and when you have a power to a power, property of exponents, that will become a negative 1/2. So we get 14 to the x is equal to 14 to the negative 1/2 power. So once we get the same base and everything into the same location, we can see that x equals negative 1/2. So that would be our answer. So simplify without a calculator, we are going to get negative 1/2. Number 7, simplify without a calculator as well. So there's another property of logs that work really nice, the cancellation property. So if the base is the same as the argument, whatever you're taking the log of, they basically cancel out. So log base 2 and the 2 cancel each other out, leaving you with 7. So if you ever notice that the base is the same as the argument, they just cancel each other out and leave you with that value. Number 8, we want to simplify the expression without a calculator. Same cancellation property is in effect here. We have 6, this is exponential form, and then it's raised to the power of log base 6 of p minus q. So just like this cancellation property, the base is the same as the argument. Same thing here, the base of the exponent is the same as the base of the log. These two also cancel each other out, leaving you with just p minus q. So these are two properties of log, cancellation properties that cancel each other out and just leave you with the argument.